Fiber optics is a technology that has revolutionized the way we communicate, work, and live. Fiber optics uses thin threads of glass in single strands or bundled by the dozens or thousands to transmit light signals over long distances. Unlike traditional copper wires, fiber optic cables are immune to electromagnetic interference, making them ideal for transmitting data over long distances with minimal loss of signal quality. Fiber optics cables have three parts: the core, made from thin strands of glass, no thicker than the width of a human hair. Around that is a glass layer called the cladding. It acts like a coating to reflect light back into the core, so the light can't escape. And the outermost layer is a buffer, usually made of plastic. This protects the fiber from moisture and damage. Let's dive a little deeper into the way fiber optics work. The process begins with a conversion of electronic signals into light signals. These light signals are then transmitted through the fiber optic cable. The cladding ensures that no light escapes the fiber as it travels. The demand for higher data transmission capacity and speeds continues to grow as network applications expand. AI use continues to develop, and organizations collect more data than ever before. This requires cabling that supports higher bandwidth, something fiber optics can deliver. So let's talk about what it takes to get fiber optic cables installed and transmitting large amounts of data. In order to make sure those tiny glass threads are transmitting data efficiently, proper installation and testing is crucial. Specialized equipment can test insertion loss, length, and reflectance to ensure that the fiber optic cable will work as intended. It's also critical to inspect fiber connector end faces when they are installed or reconnected to ensure they are free of contamination and clean them if they aren't. Fluke Networks offers the specialized equipment needed for the installation and certification testing of fiber networks. The pocket-sized FiberAlert live fiber detector to quickly verify fiber activity, polarity, and connectivity. The VisiFault Visual Fault Locator, or VFL, finds faults, verifies continuity and polarity. Fiber QuickMap is a multi-mode fiber distance and fault locator. This fills the gap between a VFL and an OTDR. OptiFiber Pro is an OTDR, or Optical Time Domain Reflectometer. It can pinpoint faults in fiber optic cabling and also be used for certification. It's designed with features and usability for both the enterprise network engineers and cable installers working in both enterprise and OSP environments. CertiFiber Pro Optical Loss Test improves the efficiency of fiber optic certification. MultiFiber Pro Optical Power Meter is an MPO tester that supports both single-mode and multi-mode MPO fiber certification. Fiber inspectors can let you know if the fiber end faces you're working with are clean enough for high-performance, reliable operation. The FI 7000 Fiber Inspector Pro can give you a 1-second automated pass-fail certification of fiber optic connector end faces. With Fluke tools, network service providers, installers, and contractors can deliver superior network performance, ensuring smooth functionality of these fiber optic cables. The advantages of fiber optics include higher bandwidth, longer distances, and less susceptibility to electromagnetic interference than traditional copper cables. However, fiber optic electronics can be more expensive and require specialized tools to install as compared to traditional copper wires. Fiber optics plays a vital role in modern communication. By understanding what fiber optics is, how it works, and how to install fiber optic networks, we can ensure that our digital world continues to thrive.